Hello everyone, welcome to the GATE and PTL lecture course. Today we are going to solve some GATE problems. A parallel plate capacitor with space T in between two plates, area of cross section A is connected to a voltage V. If the plates are pulled apart quasi-statically to a spacing 2D, then which of the following statement is correct? What is the force at a spacing of 2D and the work done between in moving the plates and the energy transferred to the voltage source and energy of the capacitor reduced by. So we have to calculate these four quantities because we have to check all these statements. So initially the capacitor have a distance d, but uniformly the spacing is changed to 2d and nothing has changed other than this. So the force between the plate is we have to calculate. See, if you have a plate like this which carry a charge sigma, so due to this plate, the electric field is already given by sigma upon 2 epsilon naught. And if you plate any other charge quantities, it may be plate, it may be a single charge Q. It is going to create a force onto this which is given by QE. So the force is given by mod E into Q. So this force we have to calculate. And since electric field due to a one plate is given by sigma upon 2 epsilon naught, so the force is given by Q times of the sigma upon 2 epsilon naught. And we can write Q as sigma, just surface charge. Q upon A is equals to sigma. So therefore we can write Q as sigma into A. So we can write, then the force will become sigma square A upon 2 epsilon naught. But the answer is given in terms of epsilon naught A V. So we have to see how V's depend on this sigma and A. So the potential V is given by E into D and E will become sigma upon epsilon naught into D between the plate. So sigma will become epsilon naught V upon D. So we have to put sigma value which is epsilon naught V square by D square and A upon 2 epsilon naught into this force equation. So A upon 2 epsilon naught is also there. So we have to see this is the force when the charge distance between these two plates is d. Now when the distance is 2d, this quantity will become 4 times of this. So 1 by 8, A is also there. So A epsilon naught V square by D square. So this is the right option. Now we have to calculate work done in moving the plates. So work done in moving the plate is work done at distance d minus work done at distance 2d, final minus initial. Okay, final minus initial means 2d minus d. So the work done is given by potential multiplied by charge. So charge Q is sigma into A. Sigma is again written in terms of V and D. Epsilon naught V upon D and V is already there. And at a distance 2D, distance is changed to 2D. And the work done is final minus initial. So these two quantities are same, so it will become 1 minus 1 by 2. So again, this will lead to work done as epsilon naught V square A by 2D. Epsilon naught V square A by 2D. So this option is wrong. We have to calculate then energy transfer to the voltage source. So basically, the energy transfer to the voltage source. So if your charge is not changing due to this work done, then the energy is already transferred to as if uh, then this work done that is done in changing this spacing is transferred as a voltage source. So this is the energy 1 by 2 epsilon V square A, which is transferred to the voltage source. Now we have to see how the energy of capacitor reduces. Now, if you look at the capacitance, it is also get changes by changing this distance G, and it is given that we have to just see how the energy of this capacitance is changes. So basically, voltage and charge is kept constant. Now, if you kept voltage and charge as constant, the capacitance energy which is given by 1 by 2 CV square. This is the formula for energy stored inside the capacitor. And in the final case, and distance will become 2D. So I just write it as like this, otherwise it will be like this. In the final case, energy will be epsilon naught A by 2D, and initial case capacitance is epsilon naught A by D. So basically, if you took the magnitude of that, it will become 1 by 4 epsilon naught A by dV square. So energy for the capacitance is reduced by this factor. So this is also correct. So basically, three option is correct in this question.